Hello everyone, in this tutorial video I would like to discuss partial derivatives, which are the most simplest type of 3D derivative. A partial derivative is known as that because you are only taking the derivative with respect to part of the function instead of all the variables at once. The notation for a partial derivative is function, subscript, variable you are taking the partial derivative with reference to. So f subscript x means partial derivative with respect to x. The computation for a partial derivative involves treating every variable except the one you are differentiating with respect to as a constant. So we substitute in b for y, where b is an arbitrary constant, if we want to take the partial derivative with respect to x. So if we know we have this function, the partial derivative with respect to x would be 4 times x times y cubed, because we know y is a constant in this derivative, so y cubed is also a constant. If we take the partial derivative with respect to y instead, this would be 6 times y squared times x squared. An interesting thing to notice is that the first order partial derivatives of a multivariable function have different values, which is not true for a single variable function. The first derivative is only one derivative. And we see the number of partial derivatives is exactly equal to the number of variables for a multivariable function. We next use a more formal / literal definition for the partial derivatives, which would be, if we are doing it with respect to x, the limit as h approaches 0 of f of x plus h comma y minus f of x comma y all over h. And by similar logic, the partial derivative with respect to y would be y plus h in the first part of the numerator rather than x plus h, but is the same limit otherwise. Alternative notations for partial derivatives are as follows. You can write f subscript variable you are taking the partial derivative with respect to without writing the x and y explicitly, or you can write it as capital delta of f over capital delta of x, or whatever you are taking the derivative with respect to. Capital delta helps you distinguish it as a partial derivative. You can use z's instead of f's because of the fact z is the output, or you can finally do capital D instead of f times f, which is not something we are familiar with from 1D derivatives, but you may see it sometimes. Now that we have figured out what partial derivatives are, both their literal definitions and computations for them, we can discuss higher order partial derivatives, or partial derivatives of partial derivatives, and how they are more messy / intricate than 1D higher order derivatives, just like first order partial derivatives are more messy than 1D derivatives. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.